Okay, and my graph, I did a much worse job on my graph this time, but y equals x is not difficult, but for y equals secant squared, I started plugging in a few different values. I had a rough idea of what the graph looks like. Looks something like this. It's not super accurate, but it was enough for me to see that between negative pi over 4 and positive pi over 4, it was enough for me to see that the secant squared was on top, which is all that really matters, because if you do bottom minus top, you're not going to get the right answer. So they pretty much told us the bounds, and now that I know secant squared is on top of x, that is the integral that would give me the area between those. If I only integrated secant squared, it would give me everything between it and the x-axis, but some of that I don't want. And the part of it that I don't want, or the part that I don't want to count double, is the part under x. So subtracting that away is how this all works out. So it's important to remind ourselves why this is working. So the thing that you can take the derivative of to get secant squared is tangent. So you don't have to know the inverse trig identities right now, but you should still know the regular trig derivatives, just not the inverse ones yet. And so then if we plug in pi over 4 the first time, tangent and pi over 4 is 1, because sine and cosine are the same there. Plug it in over here, I get pi squared over 16 times a half. Okay, and then minus, plug in negative pi over 4. Tangent at negative pi over 4 is negative 1. Sine and cosine are equal there too, except one's positive and one's negative. And then plug in negative pi over 4 here. That would give me minus pi squared over 16 times a half. And so in the end, it looks like I've got a 1, and distribute this plus a 1 gives me a 2. I've got a negative pi squared over 32, and if you distribute this, you have a plus pi squared over 32, so those are going to add up to 0, and so then in the end, all of that mess simplified out to be 2.